Welcome to Lesson 14, Work, Energy and Power, arguably the single most useful concept in all of physics. Here's the plan for today. We start with the most important principle, the one that underpins everything. Energy cannot be created or destroyed. It can only be transferred from one store to another. Nothing ever disappears. If energy seems to have gone, it has actually gone somewhere else, usually as heat, sound, or distortion. A swinging pendulum shows this beautifully. At the top of the swing, it's momentarily still. All of the energy is gravitational potential. There is no kinetic energy. At the bottom, it's moving fastest. The potential has become kinetic. And back up on the other side, it converts back to potential. The total stays the same, and that lets you jump from one point to another without worrying about the messy details in between. Doing work is how we describe energy being transferred by a force. It's the force multiplied by the distance moved in that direction of the force. W equals Fd cos theta, where theta is the angle between the force and the displacement. This is measured in joules. That cos theta is worth pausing on though. If the force is perpendicular to the motion, theta is 90 degrees and cos of 90 is 0, so there is technically no work done at all. This sounds odd, but think about carrying a heavy bag horizontally across a room. You're holding it up, but your upwards force is at right angles to your horizontal motion, so strictly, in physics terms, that force does no work on the bag. Perpendicular force means no work. The first of the two energy equations that you need to know, kinetic energy, the energy of motion, is a half mv squared. And notice that v is squared. Interestingly, if you double your speed, you quadruple your kinetic energy. That's the same relationship that made braking distances scale so badly with speed in Lesson 12. It's the same physics. The second is gravitational potential energy, the energy we gain from moving a mass up to a certain height. The change in energy is mg delta h, mass times gravitational field strength times the change in height. Lift something higher and you store more. We'll see later on that little g is not constant, but over small distances we can take it to be that. And here's the trick that makes these so powerful. You can equate them. A falling object converts mgh into a half mv squared, and setting those equal gives you the speed at the bottom, with no forces or suvat needed at all. Power is defined as the rate of energy transfer, energy over time, or work done over time. Measured in watts, 1 watt is 1 joule per second. There's a second form that's extremely useful but often forgotten. Power equals force times velocity. P equals Fv. It comes straight out of the definition. Work is force times distance, and distance over time is velocity. So the distance and time collapse into a v. So if a car pushes with a certain driving force at a certain speed, you multiply them together and you have the power output directly. Finally, efficiency, the useful output energy divided by the total input energy, times 100 to give a percentage. This means that there are no units for efficiency. The word doing the work there is useful because the input energy always splits, with some going where you want it and some going to waste, almost always as heat. And energy can never exceed 100%. If you ever calculate more than that, unfortunately you will have made an arithmetic error, because that would mean creating energy from nothing, and we established in the very first slide that that's off the table. That's the end of the video, and the end of the topic on energy and motion. Next time we start materials, starting with density and Hooke's law. Thanks for watching, check out my tutoring page below.